Alrighty, hello everybody, and welcome to video 2 for the floors on queues. In the first video, we wrote queues for bodies. We did enqueue, dequeue, size, and empty. And when we ran the self-test queue command, all of our checks came back green as passing. The front method was provided for us. Today, we're going to use that queue for the first time on the classic exercise called hot potato. We're going to pass a token around a circle and eliminate every kth person. And so the question then becomes, who survives? So today's edit is going to center around one function in one file. We're going to go under the hero/potato.cpp file, and there's a function called hot potato that takes in the parameters of names and k, and it's going to use a queue that takes a standard string type. Now, main.cpp's potato, and there's a thing there for us to use name in angle brackets and k. The command's already wired right now to call this function. Right now, it just prints hot potato is unimplemented because the stub returns that placeholder. But after this video, it's going to return the real survivors of the hot potato exercise. Really, nothing else changes here. Our queue header file stays the same, and our potato.cpp file already includes that. Okay. Now, of course, let's run this just to show you kind of where it's at now and to show you the stubbed version here when we build this, where it just says hot potato's not ready, right? So notice here we have this potato name k command right here. So I'm going to go ahead and say potato A, B, C, D, E, and then we're going to eliminate every third entry. And you see I run that command, of course, it says back, hey, the survivor is, then this says hot potato is unimplemented, okay? So we're going to actually make it play the game here today. And the only tool we need to actually play this is what we built in the last video, is what we need is a queue. This is the canonical thing that a queue is for. Anywhere you have to take turns in the order people arrived and send each one to the back when their turn passes. So let's go ahead and open up our hero potato.cpp file. Did you ever think you'd be opening a CPP file named potato? There you go. The things that we find ourselves in here. Okay. Perfect. So here's going to be the file that we need to work with here. Okay. But I think what could be helpful is actually let's write the algorithm down. I want to also open us up a notepad and let's just talk through the algorithm as well. Okay, so before we write code, let's perform the algorithm by hand, so to speak. Okay, so what we need to know is the rule for this algorithm is every round, the next k-1 people are safe. They walk from the front to the back of the line. And then the kth person now at the front is out. So they're removed. So k is going to be 3. So each round, 2 people go to the back, and the third is eliminated. Okay. So let's walk it with me. So say our starting setup is we have A, B, C, D, and E, and the front is A. So round 1, A is safe. It goes to the back, meaning that we now have B, C, D, E, A. B is safe as well. Let me tab over here. So B is also safe. It goes to the back. There's C, D, E, A, B. And then, of course, C is third. Therefore, it's out. So then we have D, E, A, B. Following with me so far? So 2 go to the back, then the next one is out. Then we have round 2. So we'll say, okay, D is safe, so it goes to the back. Okay, so we have E, A, B, D. Okay. Um, let's see, D, E, A, B. Yeah, so E, A, B, D. Sorry, I was getting confused there with my C, but C actually got knocked out. So we have E, A, B, D. Of course, then we have E is safe as well, so it goes to the back. So we have A, B, D, E. Now, in this point right here, A is now at the front, so A is front, therefore it's out. So in that case, we have B, D, and E left. Okay. So then we have round 3. Of course, B is safe, so it goes to the back, meaning we have D, E, B. Then, of course, we have D is safe, so it goes to the back. So we have E, B, D. And then E is third, so it's out. So we have B and D. Okay. Then we have round 4. Of course, B is safe, so it goes to the back. So we have DB. We then have D is safe. It goes to the back. BD. And then we have B is third. So it is out. So we just left with D. So D would be the winner of our hot potato elimination round. So notice what each safe, therefore is back move is. You read the front, you put a copy at the back, you drop the front. That's enqueue the front, then dequeue, essentially. And the elimination is just one more dequeue. The whole game here is really front slash enqueue slash dequeue, and really nothing else. No indexing, no jump to position of K. That is why it's a queue. A queue is exactly the tool that lets you take turns in arrival order and recycle the ones who aren't out yet. So let's now go ahead and write what we just did here. Okay. So let's go down to our hot potato CPP here. Now, of course, we need to replace this right here. We have a constant reference here, standard vector that takes the type string, and we're going to call this names here. And then we'll have our standard size T that will be our K. And then let's fill out this body here. So what do we need here? Well, what we need is we need to say if our names are empty, then we will return just an empty string there. Otherwise, we're going to say Q type string. We'll call it Q. And then we'll say for const standard string ampersand in names there. We're going to loop through. We'll say while our Q.size is greater than 1. Right, so that's our looping condition to keep us cycling through here. We'll say for standard size T, I equals 0, I less than K minus 1, plus plus I. Okay, so while we're in that loop, I'm going to say Q.enqueue. What's at the front? And then I need to dequeue. And so that's all I need to do in that for loop there. Perfect. So then we can step out of that for loop, and then at the end of that, I'll do me one more dequeue. And then once I get outside, let's see, let me count my braces here. I need to make sure. So we have our function brace, have our if, we then have our queue, we then have our for loop. Let's see. Actually, this one should just be, we don't need a brace right here. There we go. I have an extra brace here. Okay. So I'll just say right here after the loop, I'm going to say I missed me an enqueue here. I need to enqueue our in here. So this is 1. And then up here, I can move this back. There we go. I'm probably being a little OCD here, but I just want to make sure I have everything good here. And then this final, we should have outside this brace our Q.dequeue. Then we have this brace, and then outside of that, with a final brace here at the end to close out the function, at the very end, we should return our Q.front, who is the individual who survived our hot potato. So this should be correct right here. So first in this function, we have our guard, okay? If the names is empty, return the empty string and stop. Now, without it, we would fall through to the last line. Return Q.front and front on an empty queue dereferences null, as we talked about before. That's what we call the underflow hazard, same family as floor 6's empty stack top. So you want to guard it up front. Next, we load the line, a queue holding type string, and we enqueue every name in the order given. That's the starting line at Quill's desk. Now we have our outer loop. So while more than one remains, when we're down to 1, the game's over, right? And then, of course, that one is going to be our survivor there. Inside, we have our rotation, a for loop that runs k minus 1 times. Each pass down does exactly the safe move to the back of the line move from the board there, from the notepad file. We enqueue the front, okay? So we put a copy. So we enqueue the front, we put a copy at the back, and then we dequeue the original front. K minus 1 of those moves the next K minus 1 safe people to the back of the line. Then we have one more dequeue outside the inner loop. Okay, that's the kth person now sitting at the front who has been eliminated. And when the outer loop finally exits with one name left, we return our Q.front, which is the last one standing in this case. So look at how little surface area this used. We have enqueue, dequeue, front, and size. 4 methods, and 4 is all a queue offers. That constraint is the lesson here. The problem fits the tool exactly. So let's save this and let's run this here and make sure we're all good to go. Okay. So let's say potato A, B, C, D, E, 3. Boom, our survivor is D. We can also try potato. Let's just do some names here. So we have Grix, Scrit, Quill, Vale, and Resh. And we eliminate the second ones there. So we see Quill survives that one. We could say potato. Maybe we have only one person there, and we do just the 7th one. So you see, even in that case, that works just fine. A potato, A, B, the first one, survivor B. Okay, so you see there, different tests there. We notice, of course, the first call, we already worked that one out, so that's fine. We also have 5 names from the bestiary with k equals 2, and the survivor is Quill himself. The steward outlasts the line, which feels right in this case. But also we have some edge cases because they teach the algorithm shape here. So using potato on only 1 and then picking k of 7, one name but k equals 7, the outer loop never even runs. Size starts at 1, which is not greater than 1, so we skip straight to return. Survivor is the only name. There's no special casing needed there. The while condition handled it there. Then, of course, potato A, B, and k equals 1. K minus 1 is 0, so the inner rotation loop runs 0 times. Nobody is made safe. Every round just drops the front. A out, B survives. K equals 1 means eliminate the front every time. And the code degenerates to exactly that with no extra logic. Okay. Now, of course, you could try even a bigger number than that too, and that would work fine. So just step back here for a second. You used a data structure you built yourself to play a game that has nothing obviously to do with linked lists, and the code is 4 queue operations in a loop. Print job schedulers, network routers, the thread waiting on a lock. It's the same shape. You take turns in arrival order, recycle the ones still waiting. You just wrote the smallest interesting version of all of them. And here's the kicker. You could not do this on a stack. A stack hands back the most recent arrival. Hot potato needs the oldest. The ADT you pick is the answer you get. Awesome. Well, I hope this was helpful for you, and I will see you in the last video for floor 7. Have a good one. Bye-bye.